the ratio and root tests. Okay, so again, these are both convergence tests for series with positive terms. So let's let u sub k be a series with positive terms, and suppose the limit as k goes to infinity of our k plus first term divided by our kth term is equal to rho. If rho is less than 1, then our series converges. If rho is greater than 1, or rho is equal to infinity, then the series diverges. And if rho is equal to 1, then we don't know. The series may converge or it may diverge. So let's use the ratio test to determine whether the series 1 over k factorial converges or diverges. First thing you do is you determine what is your kth term, 1 over k factorial, and what is your k plus first term. So that's 1 over k plus 1 factorial. And notice you have to put parentheses around that k plus 1 factorial. If you left the parentheses off, then it would have been k plus 1 factorial, which is just k plus 1. Totally different. So be really careful that you put the parentheses in there. Alright, so rho is equal to the ratio of our k plus first term over our kth term. So that's equal to the limit as k goes to infinity of 1 over k plus 1 factorial divided by 1 over k factorial. Just rewriting our terms by flipping to denominator, we get this equation. Now remember, k factorial is just k times k minus 1 times k minus 2 down to 1. And k plus 1 factorial is k plus 1 times k minus 1 down to 1. When we write it this way, you can see that all the terms in red are the same. So they're going to cancel each other out. So this simplifies down to the limit as k goes to infinity of 1 over k plus 1, and that's equal to 0. Since this value for rho is less than 1, we know by the ratio test that the series converges. Alright, let's use the ratio test to determine whether the series k to the k over k factorial converges or diverges. Oh, that looks really cool. Look at all those k's. Alright, so here we go. The first thing is to determine your kth term and your k plus first term. And it's really important that you have parentheses in the right place. Alright? Once you've determined your kth term and your k plus first term, you look at the limit of their ratios. You simplify it by flipping the denominator. And again, what do we have? We have this term here times k factorial. And then k plus 1 factorial we can write as k plus 1 times k factorial. And once we do that, you can see that the k factorial and the k factorial here are going to cancel out with each other. And here I have a k plus 1, and here I have k plus 1. One of those will cancel out. So this simplifies down to this, where my k factorials cancel out. And then one of those terms of k plus 1 are going to go away. So rho is going to be equal to the limit of k plus 1 over k to the k. Or just rewriting that, it's a limit as k goes to infinity of k plus 1 over k to the k. Alright, this is actually a familiar limit for us. If we rewrite this as 1 plus 1 over k raised to the k, this limit here we know is equal to e, and e is greater than 1. So since rho is greater than 1, the ratio test tells us that the series diverges. Alright, now let's determine whether this series, 1 plus 1/3 plus 1/5 plus 1/7 and so forth, converges or diverges. Alright, so the first thing is you determine what your k plus first term is. What your kth term is. And then you determine what your k plus first term is. And again, remember, use parentheses. I'm plugging in instead of k plus 1. Make sure there's parentheses around it. Now, rho is going to be equal to the limit as k goes to infinity of the ratio of those terms. Plugging in those values here, and then simplifying by multiplying by the reciprocal here, we get that this limit is going to be equal to 2k minus 1 over 2k And then when you simplify this, you end up with plus 1. This is a rational function where the degree of the numerator equals the degree of the denominator. So this limit is going to be equal to the ratio of our leading coefficients, 2 over 2, which is equal to 1. Now, the ratio test doesn't tell us if the series converges or diverges because rho is equal to 1. So what do? Well, you don't just stop and give up. You say, I know a lot of other tests to figure out if a series converges or diverges. So what I'm going to do is I'm going to use one of those other tests. In this case, what we can use is the integral test. If we look at the integral from 1 to infinity of 1 over 2x minus 1, that's an improper integral. We rewrite it with limits. We evaluate the integral. Look at the limit as L goes to infinity. This term's going to go to infinity. So the whole thing, the integral test tells us this integral diverges, which tells us that our series also diverges. All right, so here's another test. This test is called the root test. It says, suppose you have a series with positive terms, and suppose that rho is equal to the limit as k goes to infinity of the kth root of your kth term. This series says that if rho is less than 1, the series converges. If rho is greater than 1 or infinity, the series diverges. And if rho is equal to 1, the test tells you nothing. It might converge, it might diverge. So let's look at an example. Let's use the root test to determine whether this series converges or diverges. To use the root test, we determine what our kth term is. And then we look at the kth root of our kth term, and we simplify it. So now we say, okay, rho is going to be equal to the limit as k goes to infinity of our kth root of our kth term. That's going to be equal to this limit, which is a rational function. The degree of the numerator is the same as the degree of the denominator. So the limit's going to be equal to the ratio of our leading coefficients, which is 2. So we found that rho is greater than 1. So that tells us by the root test that our series diverges. Let's use a root test to determine whether this new series converges or diverges. 1 over the natural log of k plus 1, all raised to the k. Oh, this looks like fun too. All right, so what do? We determine our kth term, and we determine the kth root of our kth term. Now we let rho be equal to the limit as k goes to infinity of the kth root of our kth term. And as k goes to infinity in this case, natural log of this part here goes to infinity, so the whole thing's going to head towards 0. So since rho is less than 1, by the root test we know that our series converges.